All right, greetings everyone. Welcome to the third part of the video now for section 7.3. Continuing on with looking at one more problem related to the double angle identities, and then we'll look at a new set of identities. All right, so we're told to use double angle identities, along with other identities to simplify the following as much as possible. So we have sine of 2x over 1 minus cosine squared. And you probably notice we have this sine of 2x here, which means we're probably going to use our double angle identity for sine, which is 2 times sine of x times cosine of x. And if we leave the bottom the same over 1 minus cosine squared of x, well, this doesn't really look like much would happen here, right? Because we can't cancel any of the cosines with this because this cosine is being subtracted from 1. So we can't deal with that. So what might we do instead? Well, make this 2 times sine of x times cosine of x. 1 minus cosine squared, if you remember from our Pythagorean identity, from sine squared x plus cosine squared x equals 1. If we subtract cosine squared from both sides there, we'd have sine squared of x equals 1 minus cosine squared of x. So we can make a substitution for 1 minus cosine squared of x as sine squared of x. So we would have this equals, and now we have a sine on the top, a sine squared on the bottom. This can cancel with this here. And so now the top is 2, whoa, did not mean to use that color. We can make this 2 times cosine of x over, we have a sine of x in the denominator. And then notice we have a cosine of x times a sine, or divided by a sine of x there, which if we think back to our previous identities, just gives us 2 times cotangent of x. Okay, so that would be as simplified as this can get. So sine of 2x over 1 minus cosine squared becomes 2 times cotangent of x. All right. Okay, let's add another set of identities to the fold. So these are our half angle identities and our power reduction identities. And so these are new identities we'll be working with. Now, I don't know if I mentioned before, but you do not need to memorize these identities, nor do you need to memorize the double angle identities. But as per normal, we need to know how to use them. And notice with the half angle identities here, first of all, what you see is an angle divided by half inside of your trig function in both of these, and then the angle not divided by half in the expressions. Also note, there's these plus or minuses on the outside of the roots here. Now, as we've discussed, the sine or cosine of an angle cannot be both plus or minus. It can only be one of those. And the one that it is, we'll make a determination with at the end of each of these problems. Okay, and I'll go over an example of that. Further, our power reduction identities, basically they're power reduction because notice they go from something being squared to a function where things are not being squared. And notice when we do that, we go from the angle we started with to double that angle in both cases. Okay, so those would be our power reduction identities. All right, so let's use those to help us find exact values for both of these expressions. So we're asked to find cosine of 22.5 degrees, as well as sine squared of 157.5 degrees. And notice that neither of those is on the unit circle. So we can't use that to help us find exact values straight away for each. So we have to use those identities we were just looking at. And for the cosine one here, we have cosine of 22.5 degrees. Well, notice I can write that as cosine of 45 degrees divided by 2. And note that if you do that, 45 degrees divided by 2, that gives us 22.5. Also, 45 degrees is on the unit circle, right? So we can use, so that's helpful. And notice now this is in the form of that cosine of theta over 2 identity we were just looking at. So based on that identity, it says as we can rewrite this as plus or minus square root of cosine of theta, which in this case is cosine of 45 degrees, plus 1, all divided by 2 inside the root. And now we get to do some fun algebra. Okay, so we're going to start by putting in what the value is for cosine of 45. So that'd be root 2 over 2 plus 1, all divided by 2. And we'll start to simplify. Now we'll start our simplifying up here on the top of our fractions. We have root 2 over 2 plus 1. Note that the 1 we can write as 1 over 1. If we get a common denominator, it becomes 2 over 2. So this expression would then become plus or minus square root of root 2 over 2 plus 2 over 2 divided by 2. Which then in the top part of our fraction there, we can combine those two. So root 2 over 2 plus 2 over 2, because they have common denominators, we can write that as root 2 plus 2 all over 2. And then that whole thing divided by 2. And if your mind is not getting boggled yet, wait for this next step now. Well, I shouldn't say that. You're not going to get boggled. There's more to do. That's what I want to say. So now notice inside of a root, we have a fraction, although a very complex fraction, but it's a fraction, being divided by something, which we can also make a fraction. We can make the 2 over 1. And so we know when we divide by fractions, we do our keep, change, flip thing. So this would become plus or minus square root of root 2 plus 2 over 2 times, instead of 1 over 2 to be 1/2, which then gives us plus or minus square root of, multiply across, we'll have root 2 plus 2 on the top, and we multiply that by 1, and a 4 on the denominator. And we can actually go ahead and leave our answer like that. We don't need to simplify anymore. And I know this might feel uncomfortable because we have a root within a root, but that is legal mathematically, so we don't need to do much more there. And then the final thing, as I mentioned before, is this plus or minus. So our answer cannot be both positive and negative. It has to be one or the other. And to determine that, we go back to the original angle we started with, this 22.5 degrees. Now 22.5 degrees is in the first quadrant. We're finding the cosine of it. We know cosine is positive in the first quadrant. Therefore, our answer down here should be positive. All right. And that gives us our exact answer for that one. Isn't that sweet? Yeah. All right, let's look at finding sine squared of 157.5. And even though we're going to find sine squared here, as you can imagine, once we get it, whatever it is, so let's say it's equal to some number, right? We could very easily take the square root on both sides to then find the actual sine of 157.5, right? So that's why this is useful for us. And again, we're going to find an exact value. Now notice here we've got the thing squared. And we prefer to work with stuff that's not squared. And I should point out, notice that the sine is squared. It's not the angle that's squared. Okay, that's a common mistake folks make. It's not the angle being squared, it's the sine being squared. And so our power reduction identity tells us we can rewrite this. Well, actually, before we do that, notice that 157 got my wires crossed there. Our power reduction identity says we can rewrite this as 1 minus the cosine of, and if we think of the 157.5 as being our A, the power reduction identity says we do the cosine of 2 times A, so 2 times 157.5 degrees. Okay, and then that whole thing being divided by 2. And if we do the 2 times the 157.5 degrees, you'll notice that we come up with 315 degrees, which is now a value on the unit circle. So we can work to find an exact value here. So we'll go ahead and put that in. 315 is in the 4th quadrant, so its cosine is positive. And if we check our unit circle, it's root 2 over 2. That's all divided by 2. We can do some fraction magic here. We'd have the 1 becomes a 1 over 1. We get a common denominator of 2 over 2. So 2 over 2 minus root 2 over 2, all divided by 2. Again, on the top, we can combine the fractions because they have a common denominator and make that 2 minus root 2 over 2. And I should point out the reason that I do 2 minus root 2 here is because they're not technically like terms, because one has a root and one doesn't, so we just leave it like that. And again, that's all being divided by 2, which you can make that 2 a 2 over 1. We are again dividing with fractions, so we have a fraction divided by a fraction. So we do our keep change flip thing there, so we have 2 minus root 2 over 2 times 1/2. Multiply straight across, we'll end up with 2 minus root 2 all over 4. That's the final answer. Okay, so the exact answer for sine squared of 157.5 degrees is 2 minus root 2 over 4. And again, if we took the square root of that, we could actually find the exact value for the sine of 157.5. All right, that's it for now. Thank you for watching.